Hi, it's Miss Young, and I'm here to talk to you today about conic sections, specifically the circle. In order to create a circle from intersecting a cone, we must make sure that the plane intersects the cone so that that plane is parallel to the base. And when that happens, we create a two-dimensional figure called a circle. On to equations of circles. There are two different forms of the equation of a circle. The first is called general form. And with general form, we will see this for every conic section that we study. General form is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. A, B, C, D, E, and F are all coefficients, so these are all constant values. For the sake of this video series, B will have a value of 0, which means that our conics will not rotate. We'll be dealing strictly with horizontal or vertical oriented conic sections. Specifically for the circle, when the values of A and C are exactly the same, then we can recognize that the general form equation will create the equation of a circle. That is, A and C must have the exact same value, same number, same sign. Moving to the right with standard form, the standard form of a circle, x minus h squared plus y minus k squared equals r squared. Whenever we can get an equation in this form, we can easily recognize the center of the circle as hk and the radius of the circle as r. Let's consider the following example. X squared plus y squared plus 12x minus 10y plus 12 equals 0. We want to be able to take this equation, which is in general form, and rewrite it so that it represents the equation of a circle in standard form. In order to do that, we must complete the square. So let's begin that process. What I will do first is to organize or reorganize the terms so that the x and y terms are together. So I will rewrite this as x squared plus 12x plus y squared minus 10y plus 12 equals 0. Now, in order to complete the square, the constant term must be on the opposite side of the equation from the variable terms. So now I will subtract 12 on both sides. X squared plus 12x plus y squared minus 10y equals negative 12. Next, I'll complete the square separately for the x terms and the y terms. X squared plus 12x. In order to complete the square for the x terms, I must take 12, which is the coefficient of the linear term of x to the first, divide it by 2, and then square it. Whatever I get by doing this, I'm going to add it to the right-hand side of the equation. So I'm taking 12, dividing by 2, and squaring it. That gives me my third term. Now for y's. I have y squared minus 10y. I'm going to add whatever I get if I take negative 10, divide by 2, and square it. Now I've completed the square on the left-hand side. I just have to complete the balance additions for the right-hand side. The original right-hand side of the equation was negative 12, which is the same number we had here. By dividing 12 by 2 in order to complete the square for x's, I get 6, and then squaring it, I get 36. So in essence, I added 36 to this expression. So I need to make sure to add 36 to the right-hand side that holds the constants. Moving to the y terms, negative 10 divided by 2 is negative 5. Squaring that, I get 25. So I've essentially added 25 to the left side. I need to make sure to add 25 to the right side as well. Now simplifying the right side, negative 12 plus 36 plus 25 gives me 49. On the left-hand side, what I have is a perfect trinomial that will factor into the square of a binomial. For x's, that's going to factor into x, and then 12 divided by 2 is 6, so that's going to say x plus 6 squared. For the y terms, I'll have y. Negative 10 divided by 2 was negative 5. So this is y minus 5 squared. And now we have changed the general form of the circle into the standard form of the circle. Now, as I move over to the right-hand side, I can pick up the fact that the center of this circle is represented by the coordinates h, comma, k, and the radius of the circle is represented by the value of r. Specifically in the equation that we have here, the center is negative 6, 5, and the radius is 7. Negative 6, 5, as the equation asks us to subtract h, so this is the opposite of positive 6, and subtract k, so the opposite of negative 5 here is 5. And in order to find the radius, we're going to take the square root of the constant term. Now for a second example. We want to write the equation for the entire set of points that are 6 units away from negative 2, negative 3. So if all of the points are the same distance away from a certain point, then what we're describing is a circle. Hopefully we would recognize that the center of this circle, or h, comma, k, is negative 2, negative 3, and that the radius of this circle, that distance that is equal from the center, is 6. So as we substitute for h, k, and r into the standard form of our equation, here's what we'll find. X plus 2 squared plus y plus 3 squared equals 6 squared. So again, this is me substituting negative 2 for h, negative 3 for k, and 6 for r. And as I complete the equation, x plus 2 squared plus y plus 3 squared equals 36. This is the equation that represents the entire set of points that are 6 units away from negative 2, negative 3. Now we're going to graph the last example that we just found an equation for. You may want to pause and take a few moments to set up your axes. Whenever we're graphing, make sure that you draw your axes, make sure you scale them appropriately, and give me numbers so that I can tell what values are being represented. You don't necessarily have to set yours up as I've done, but you do need to consider where the center of your circle will be and also what the radius is so that you know in what direction to move up, down, left, and right from the center in order to create your circle. So press pause. Okay, welcome back. Now we're going to graph the last example where we were 6 units away from negative 2, negative 3. As we begin to graph this, I want to make sure that we start with the center. So if my center was at negative 2, negative 3, then this point represents the center of my circle, and I'll label it with C to show that. Now if my radius is 6, that means as long as I'm 6 units away from the center, I'll create a circle. So moving from the center, I will literally count 1, 2, 3, 4, 5, 6. And then back to the center, I'll go down 1, 2, 3, 4, 5, 6. From center left, 1, 2, 3, 4, 5, 6. From center right, 1, 2, 3, 4, 5, 6. Now, the goal is to draw a nice circle. I have some tools here that are going to help me out, so I'm just going to use a compass. But I don't mind if you do your best to sketch the circle as nicely as you can. Okay, you can see the outline of my circle here. Even with the compass, there's a little trouble getting the circle nice and round. And that's why I say you can just do the best that you can with the circle, drawing it in. You don't have to worry about being a perfectionist on it so much. It's just as long as you have the important features labeled. So again, here I have a center of negative 2, negative 3, and you can just draw in one of those vertical distances to show that the radius of your circle is actually 6. Make sure that you watch the video as many times as necessary in order to get a good idea of what's supposed to happen with the equations and the graphs of the circles themselves. And I look forward to talking to you again on the next video.